Welcome to this investigative explainer. Today we're taking a deep dive into one of the absolute most tragic and honestly defining moments in the history of space exploration. It's a story of incredible human bravery for sure, but it's also about a catastrophic intersection of mechanical failure and, quite frankly, systematic organizational negligence. All right, let's get right into it.
Millions of people watched live as NASA's Challenger space shuttle lifted off into the sky. Just 73 seconds later, the mission ended in disaster.
Part 1. The Space Shuttle Era and the Teacher in Space.
So, to really understand how we reached that devastating moment, we've got to go back to the origins of NASA's Space Shuttle program. The whole idea was to usher in this brand new era where spaceflight wasn't just for test pilots anymore. It was supposed to be routine, frequent, accessible. And the orbiter known as Challenger, it was an absolute workhorse of the fleet. This specific mission, STS-51L, was slated to be Challenger's 10th flight, but, this one was different. Back in 1984, NASA announced the Teacher in Space project. It was a massive PR triumph, really designed to get kids excited about math, science, and space again. Out of over 11,000 applicants, an elementary school teacher named Krista McAuliffe was picked to be the very first civilian in space. Because she was on board, this wasn't just another launch. It captured the whole world's attention. School children all across America literally had televisions rolled into their classrooms to watch this happen live in January 1986.
Now, before we dig into the technical failures, we absolutely have to honor the 7 crew members who boarded the shuttle that morning. Just an extraordinary, diverse group of people. You had Commander Dick Scobie, pilot Michael J. Smith, mission specialists Judith Resnick, Ellison Onizuka, and Ronald McNair, along with payload specialists Gregory Jarvis and, of course, Krista McAuliffe. Like President Reagan said later, these were daring, brave heroes with this immense hunger to explore the universe. They knew the risks, but they went anyway to do their jobs brilliantly.
Part 2. The Eve of Launch.
The dangers the crew faced were actually drastically worsened by decisions made on the ground. When you look at the timeline on January 27th and 28th, the literal eve of the launch, it reveals this incredibly tense and ultimately totally flawed decision-making process. The big issue? The weather. Up until this mission, the absolute coldest temperature for a shuttle launch was 53 degrees Fahrenheit. But on the morning of January 28th, the temperature at the Kennedy Space Center completely plummeted. We're talking well below freezing, hovering right around 28 to 29 degrees. As you can see, this wasn't just a minor anomaly, it was a massive, unprecedented drop from any previous launch conditions.
And this freezing weather set off major alarm bells for the engineers at Morton Thiokol. That's the contractor who made the solid rocket motors. Engineers like Alan McDonald and Roger Boisjoli explicitly, vehemently argued against launching. They were terrified that the rubber O-rings, these absolutely critical components that seal the joints between the rocket booster segments, would lose their resilience and just fail in those abnormally cold temperatures. But during these intense late-night communications, NASA management and Thiokol executives basically overruled the engineering judgment. They approved the launch, trading technical data for what they called at the time putting on a management hat.
Just look at the insane disparity in how risk was viewed between the two groups. The working engineers estimated the chance of a catastrophic failure at roughly 1 in 100. But NASA management, they claimed the risk was 1 in 100,000. Just to put that into perspective for a second, a 1 in 100,000 risk basically means you could launch a space shuttle every single day for the next 274 years and only expect one single accident. That is a fantastic, completely unfounded faith in the machinery. And because of that, key flight safety issues, like a very well-documented history of O-ring erosion on previous flights, were just completely bypassed and ignored.
Part 3. 73 seconds. Real quick, before we keep going, if you're enjoying these explainers that uncover the stories behind history's defining moments, subscribe to Golden Fern. Every week, we bring you fact-based investigations that go beyond the headlines. All right, let's walk through the tragic sequence of events on launch day. At T-minus 6.6 seconds, Challenger's main engines ignited. At T0, the solid rocket boosters fired up, and the massive shuttle stack lifted off Launch Pad 39B. But almost immediately, launch cameras caught a puff of black smoke right at the field joint on the right-hand booster. The O-rings had in fact failed to seal against the hot, pressurized gases. But then, right around T+2 seconds, something crazy happened. A piece of unburned solid fuel from inside the booster shifted into the joint and actually created a temporary makeshift seal. That fragile little seal somehow allowed the launch to proceed normally for about 40 seconds. But eventually, the intense heat and extreme aerodynamic pressures were just too much. At T+73 seconds, a catastrophic structural failure occurred, and the vehicle completely disintegrated in the sky. The crew compartment just kept going on a ballistic trajectory before tragically impacting the Atlantic Ocean. The entire nation was just plunged into immediate shock. Later that day, President Ronald Reagan actually altered his planned State of the Union address to speak directly to the grieving country. He delivered this incredibly poignant, unforgettable eulogy. He comforted the families, and he spoke directly to the millions of schoolchildren who had just watched the disaster unfold. He finished with that famous line, saying we would never forget the crew as they waved goodbye and slipped the surly bonds of earth to touch the face of God.
Part 4. Uncovering the Truth. So, that intense period of mourning was almost immediately followed by a massive demand for answers. President Reagan appointed an independent panel, the Rogers Commission, to investigate exactly what happened, and they uncovered the truth despite facing a ton of bureaucratic friction. The commission had some huge names on it, like astronaut Sally Ride and theoretical physicist Richard Feynman. Now, behind the scenes, Sally Ride secretly slipped fellow Commission member General Donald Kutina some internal NASA test results, and those results showed that the O-rings got stiff when they were cold. Kutina then sort of subtly prompted Feynman to look into the cold weather effects, pointing him right at the mechanical root cause that NASA management had ignored.
And that tip led to one of the most famous moments of the entire investigation. Feynman was getting super frustrated by NASA's lack of clear communication, so during a televised hearing, he did this brilliantly simple demonstration. He just took a piece of the rubber O-ring, compressed it with a standard C-clamp, and dunked it into a glass of 32-degree ice water. When he took the clamp off a few moments later, the rubber didn't stretch back. It had absolutely zero resilience at that temperature. In just a few seconds on national TV, using nothing but a clamp and ice water, Feynman proved without a doubt that those high-tech O-rings were completely unsuitable for the freezing weather on January 28th.
But here's the thing. The Rogers Commission and later sociological studies revealed that this wasn't just a technical failure of some rubber seal. Sociologist Diane Vaughan coined the phrase normalization of deviance to describe the true root cause. This was a deep, institutionalized culture at NASA where accepting deviations from safety norms, like seeing O-ring erosion on previous successful flights, just became totally routine. Instead of seeing that erosion as a giant flashing red warning sign, NASA just accepted it as normal. It was this slow, incremental descent into poor judgment, driven largely by the massive pressure to keep up a frequent launch schedule. Basically, as the Commission noted, this was an accident rooted in history.
Part 5. Legacy and Lessons Learned.
The disaster grounded the Space Shuttle program for nearly 3 years, while NASA underwent intense structural redesigns and some major cultural overhauls. And one of the key people who helped shape this new legacy of safety was Alan McDonald, the very same engineer from Morton Thiokol who had vehemently tried to stop the launch. Initially, the guy actually faced severe repercussions and was essentially demoted, but his totally honest, courageous testimony before the Rogers Commission vindicated him, and Congress powerfully reinstated him. McDonald even went on to lead the redesign of the solid rocket booster joints, directly making future missions safer. His story really brought worldwide focus to engineering safety, the massive dangers of structural secrecy, and why ethical decision-making is so crucial. As he used to tell engineering students, the ultimate lesson is to do the right thing for the right reasons at the right time with the right people, and you'll have no regrets.
The tragic loss of the Challenger 7 is this constant reminder that the very edge of human exploration is always inherently dangerous. But it also serves as a stark, permanent warning that fantastic faith in machinery can never, ever replace sound engineering judgment. Was Challenger destroyed by a failed rubber seal, or by a culture that ignored repeated warnings? If you enjoyed this explainer, please like and subscribe to Golden Fern, and tell us in the comments which historical event we should investigate next. Thanks for watching, and we'll see you in the next explainer.